So I read an article the other day by a guy named Erdal Tutar, and he's from Turkey, hence the cool name, and he interviewed 227 pre-service teachers, meaning that before they become teachers, they were like seniors in college or just about to become teachers, and he asked them an open-ended question that pretty much asked, what's the difference between solid, liquid, and gas? And he took all of that data and he put it together and he found out that there were actually a lot of misconceptions about states of matter. Like even those people who were becoming teachers didn't actually know solids, liquids, and gases all that well. And so we always think we know solids, liquids, and gases. I mean, look at these pictures. That's a solid, that's a liquid, and that's a gas, right? Right? So we know everything, right? Well, no, we actually don't. And so in this video, there's a lot of things I'm going to reveal to you, a lot of questions I'm going to probe you with. And so answer the questions as I go through, and then I'll do a little explanation after each one. Your first question relates to the number of particles in a solid, a liquid, and a gas. So let's say we took this ice right here, and we melted it, and then we turned it into a gas. Once we turned it into a gas, compare the number of gas particles versus the number of ice particles. Would there be any difference between the number of particles? If you answered no, you are correct. All right, there would be no difference between the number because think about it. All right, law of conservation of mass says that matter can't be created or destroyed. So even if we heat up this ice, turn it all into a liquid, and then turn it into a gas, we're not like destroying any of this ice or any of this water. We're just changing the state of matter. So anyway, that's the first misconception that people have, is sometimes they think that changing a solid into a gas somehow makes matter disappear or just makes gas particles less, the number of them less, which is just not true. Question number 2, do gases actually have weight? Do they have any weight? If you answered yes, you were correct. All right, weight, remember, is the force of gravity on an object. So anything that reacts to the force of gravity has a little bit of weight to it. And gases, just because they float around in the air, doesn't mean that they're not affected by gravity. Believe it or not, air is actually pulled down by gravity just like anything else is. So it's kind of a confusing concept because you think, well, air is just floating. It just bounces around freely. Well, if it was able to bounce around freely, then wouldn't all the air on Earth just fly into space? Yeah, think about that one. No, it's actually pulled down to the Earth just like anything else is. Next question, are gases lighter than solids? If you answered no, then you are correct. All right, gases and solids are like the same mass. All right, they have the same amount of matter. They have the same number of particles, so whether you turn it into a gas or you leave it as a solid doesn't mean that there are any more or less particles. It's the same amount of mass, and so try not to get confused by that. I think diagrams like this one below here can kind of confuse us because if you were to count the particles of solid here, there are more than the particles of gas. So according to this picture, this solid weighs more or has more mass than this gas does, but in general, when you're speaking about mass and how much something weighs, all right, a solid and a gas are going to weigh the same. Question number 4. Are the particles in a solid, gas, and liquid the same size, or are they different size? Are they the same size, or are they a different size? Remember, we're talking about the same thing. Let's just use, ice, water, steam. Are they the same size or a different size? If you answered that they're the same size, you are correct. If you answered that they're a different size, you're wrong, all right? And that just goes back to the same thing, law of conservation of matter. If a particle is like this size when it starts, when it turns into a liquid, it's still going to be that size. And when it turns into a gas, it's still going to be that size. It's not like you're cutting the atoms in half, all right? You're just changing how they're moving. So a solid changing into a liquid just means that the particles are more free to move. Same thing with a liquid to a gas, the particles are now separated from each other and they bounce around. So same size particle, just different movement. Question number 5, do all solids have a definite shape? Do all solids have a definite shape? The answer to that one is no, they don't all have a definite shape, even though these pictures kind of make you think that they all have a definite shape, which these do. All right, these two solids do, but take, for example, if I were to crush all of this up, or I took this rock and just put it in a mill and just crushed it up into powder, would that powder have a definite shape? I mean, if I put it into a container, would it actually kind of fill the container and take the shape of the container? Yeah, it would. I mean, so solids like sand or like this, like powdered anything, is going to take the shape of its container. So don't always think that they have to have this specific defined shape all the time. Question number 6, is there any space between particles in a solid? Answer to that one is yes. All right, there are spaces in between the solid, even though you might think, oh, no, 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 like Mr. Weiss, that rock has no space. Those particles are like touching, there's no space. But believe it or not, even though it's a solid, there's some space in between. This is more obvious in some solids than others. For example, water, when frozen, actually expands a little bit. The water molecules, the little Mickey Mouse molecules, actually arrange into little hexagons, leaving that space in the middle of the hexagon wide open. That's why when you freeze water, it expands. It actually gets bigger. And so, depending on the solid, some solids have more space between the particles than others, but just because it's a solid doesn't mean that it has no space in between the particles. It just means that they're kind of locked in position where they are. Which brings me to my next question. Can the particles in a solid move? Answer to that one is yes, they actually can move. They do move. They're always moving. Particles in a solid, just because it looks like they're not moving. Like when I look at that rock, I'm like, the particles in the rock aren't moving. I mean, it doesn't look like they're moving, right? Well, I mean, they actually are. And it's hard. Like you look at a rock and then you look at water that can be like poured and moves around. You look at gas that like flies all over the place. And you look at a rock and you're like, well, duh, the rock isn't moving. The particles can't be moving. But they really are, guys. The particles at the microscopic level are stuck in one place, but they're vibrating in place. So I guess that's how I would describe a solid, as particles vibrating in one place. Same thing with sand. Even though the sand can flow and whatever, I mean, it's the particles in sand are even vibrating in place. All right, next question is true or false. I'm going to reword this slightly here from what's on the screen. So matter that can be poured is always a liquid. Matter that can be poured is always a liquid. If you answered false, you are correct, because just because it's a liquid doesn't mean that it's the only thing that can be poured. I mean, sure, all liquids can be poured, but what else could be poured? Sand. I mean, sand's not a liquid, okay? What if you had some gas? Like dry ice, like CO2, the cool, like, Halloween-y stuff? You can pour CO2. You just tip the pitcher over and it, like, comes out. There's a lot of gases that you can pour, so just because it is a different state of matter other than the liquid doesn't mean you can't pour it. And the last question, do gases have volume? Answer to this one is yes, they do have volume. I don't know if you guys understand volume completely, but volume is how much space a substance takes up. It's how much space a substance takes up. And so gases are really unique because whatever amount of gas you have, whether it's like 1 milliliter or 1,000 milliliters of it, it's going to take up and fill up whatever room it's in for the most part. That's not always true. Like if you have a gas that's really dense or something, it might just sink to the floor, But for the most part, gases are going to spread out and kind of diffuse through the space that they're in and fill that space. Liquids, on the other hand, a glass of water is not going to fill the room that it's in. It's always going to kind of shape to the bottom of the container of whatever it's in. Solids are going to do the same kind of thing. They're going to just take up a certain amount of space. If it's like sand or something like that, it's going to fill its container, the bottom of it. But nonetheless, they all have volume. Every single one of them does. Just because you can't see a gas sometimes doesn't mean it doesn't have volume and take up space. Well, guys, that is it for today. I hope you were confused on a couple of these. I hope you got challenged a little bit, because when you are confused, when you are challenged a little bit, it helps you sort of rethink what you already know. And so I know in other classes previous to this and whatever you've been taught about solids, liquids, and gases, but many times, even myself, I kind of think I know something, but then I really don't know it very well. So just knowing the difference between a solid, liquid, and gas isn't really enough to really understand solids, liquids, and gases. And so I hope this was helpful at really getting to the nitty-gritty of what a solid, liquid, and gas is and kind of how they're different from each other. Take care.